I hope you guys have understood and seen the theory of total probability, because the idea extends to Bayes' theorem from there. Now, we know this. So these are all different disjoint events, right, within the sample space. And say this is our event A. It is derived from all the events which are disjoint, right? So Bayes' theorem answers this question. You know what event A has happened? What is the probability that it is because of this space? Say we'll call this as E10. Okay, so basically it helps us answer the question. We know that A has happened. What is the probability that it is from this space? Okay, so that's what it answers. Please understand this diagram. Please understand what we are trying to indicate. We have been using or coming to this point directly and indirectly from many classes, right? From your different grades and all of that. Together, you will be able to think of this using sets, subsets, right? Those topics, and you have probability of from different grades put together. We come into this point. So again, we have the event A already happened. Now we are trying to figure out what is the probability that it happened within this space. Right, guys? So that's the whole theorem. Got it? So how will we prove it? Well, it's quite simple. So the question is, I know that A has happened, right? What are the chances that it is from EI? So how do you read this as? Probability of the happening is from EI given A has happened. So whatever outcome has to happen, it has happened. So whatever defective product we have to get, we have got it. So what are the chances that it came from machine 1? Or we can answer questions like a person has got a 6. Right? We have seen this in one of the videos. What is the probability that it is actually telling the truth? Right? So such questions can be answered with Bayes' theorem, and which is built on the total theory of total probability. Right? Okay. Now, how do we prove it? So we know that this is conditional probability, and we can end up writing this particular formula. Okay. And the numerator, right? So we know that as per, so what is this? Multiplicative theory or rule of probability actually. So as per that, what do we have? P of A intersect EI can be rewritten as P of EI into P of A given EI. Is it not? So this is one of the ways in which we can obtain the intersect between A and EI. So we have seen this. Okay, so we have two different ways. So that would be your numerator. Next, for the denominator, so as per the theory of, you know that, as per theorem of total probability, total probability. So what do we have? P of A can be written as sum of I is equal to 1 to n probability of EI into probability of A given EI. Okay, so this is the whole funda. So substituting all of this, on substituting above into probability of EI given A, what do we end up with? We end up with the Bayes. Okay, we end up with the Bayes theorem. So what are the chances that A happened? It's because of E1 is equal to probability of EI into probability of A given EI divided by summation of probability of EI into probability of A given EI, where I will run from, okay, actually it's confusing. Here also it's I, there also it's I. So let me make this as say J or something, or I'll make this as J, I guess. J is running from 1 to N. Okay, yes. So this also I'll change. Let's call this as J itself. J, J, and J. Yeah. Okay. Right. So don't worry, we'll make use of it. I'll use the same concept, use similar diagram and all of that. So I'll give you guys a sample of it. So pretty much this video summarizes the nature of work that we'll do. So first we'll look into this entire sample. Along the x-axis, we'll divide those region E1, E2 and all of that. So that is generally called as hypothesis probability. Don't worry if you don't exactly use these words over here. But yeah, that E1, E2 is divided along the x-axis in this manner. And along the y-axis, we'll have the evidence that is A1 from this space, A1 from this space. Let me show this. So that's your A from there, A from here, and so on and so forth. And the formula will look something like this. See, basically, we are trying to figure out what is the probability that whatever happened, favorable event happened, it's because of the hypothesis. That's the general funda of, or the funda of your Bayes theorem. So the formula, it looks something like this. So you can see the highlighted things. So P of H represents this entire region. This is P of F given H. So same thing with the denominator. Denominator will pretty much add all the A's from everywhere. Okay, that's what we are doing. That's not hypothesis. That represents not, that symbol. Alright guys, so we'll use something like this and we'll be able to do the numericals. But I hope you guys got the funda. It's a very simple thing. Just understand in a simple manner. Take those 3 machine example. Take those person who lies and all of that example. Understand with example. Just don't think of the theorem. Understand from the point of view of example. It will make sense.